Good morning, students. I am Nagamani, JL Chemistry Naidupeta. Today we are going to learn about the D and F block elements. D and F block elements. What are D and F block elements and where they are located in the periodic table? So we will first of all, what are D block elements and what are F block elements? What are D block elements and then what are the F block elements? So D block elements are the elements which are filling with the d orbital. We have already known that what are the block elements, that is s block, p block, d block and then f block. So we have already known the what are the s block elements, what are p block elements, what are d block elements and then what are f block elements. So the block elements are defined as they are the elements, the electron, the differentiating electron or the newly entering electron which enters in that particular orbit. So they are called as belongs to that block element. In d block element, the differentiating electron enters into the d orbital, whereas in the f block elements the differentiating electron enters into the f orbital. So they are called as the d and f block elements. So next we will go to the where are the D block elements? D block elements consists of 3 to 12 groups. In D block elements there are 3 to 12 groups. So these are all belongs to the D block elements. They are located in between the S block and then in between the S block and the P block elements. So that is they are the lengthy periods. So the d electron will progressively entering into the 4d series. The d electron and progressively entering into these 4d series. So what are those 4d series? First one is 3d series and second one is the 4d series, 5d series and then 6d series. So in 3d series it is completely having the 10 elements in the 3D series as well as in the 4D series and the 5D series also. Whereas in the 6D series, it is incomplete D series. 6D is the incomplete period. So that is about the basics of the D block elements, and next we will go to the F block elements. Here the F block elements are located in the two periods below the periodic table. Below the periodic table, they are called as the lanthanide series and then actinide series. Lanthanide series and the actinide series. What are lanthanide series and what are actinide series? Lanthanide series elements are from 58 to 71. 14, these 14 elements are called as the lanthanide elements. 14 elements are called as lanthanide elements. They belongs to 4F series. And next actinide series, they are from thorium to lawrencium. Thorium to lawrencium, that is from 90 to 103. These 14 elements belongs to 5F series. So 4F series are called as the lanthanides, whereas 5F series they are called as the actinides. So that is the fundamentals of the D and F block elements which are present in the periodic table. And next one we will go to the so here in 3D series the first element is scandium. In 3D series the first element is the scandium and the last element it is the zinc. Whereas in 4D series it is the first element is yttrium and last element is cadmium. In 5D series that is first element is hafnium and last element is the mercury. So here we will omit the cerium to lutetium. We will omit the cerium to lutetium. And next 5D series, that is, and 6D series is the incomplete series. So these are the about the D series elements. And next one is the next we will go to the The study of incomplete filling of d orbitals in their atoms. Incomplete filling of d orbitals. The study of incomplete filling of d orbitals in their atoms make the study of d block elements different from the main group elements. Different from the main group elements. And then the valence is also applicable for the main group. That means in which main the d block element it is in which it belongs to that particular period. It may be third period or to the 12th period. According to that period the valence may vary. So that is the applicable of the valence of the main group elements. And next, in d block elements there are precious elements and then industrially important elements. Industrial important elements. So what are the precious elements and what are the industrial important elements? What are the precious elements means here they are the platinum, gold and then silver. So these are the precious elements. And industrially important elements are iron, nickel, chromium and titanium, copper. These are the industrially important elements. So these are so we will go a number of elements, a number of metals which are most useful for our daily life. They are present in the D block itself. And next one is the this chapter. In this chapter we should know we should deal with the electronic configuration, number of characters of D block elements. That is, first one is the electronic configuration. First one it is electronic configuration of the D block elements, and second one is the general properties of D block elements. General properties of the D and F block elements, and third one is the preparation and properties of D and F block elements. Preparation and properties of some particular compounds in the D block elements. And next one, these are the main important features in the D block elements or in this chapter, that is electronic configuration, general properties and preparation and the properties of the D and F block elements. So here we have the elements in 3D series, that is from scandium to zinc, whereas in 4D series they are yttrium to cadmium. In 5D series that is lanthanum to mercury. In 6D series it is incomplete. We have already known this. So the first element is scandium, yttrium and lanthanum, whereas the last element in each D series, that is zinc, cadmium and then mercury. That means here we will go for the general electronic configuration. That is the general electronic configuration of these D block elements. It is NS1 to 2, N-1D 1 to 10. So N-1D orbital, it is called as the penultimate shell. N-1D is called as the penultimate shell. This penultimate shell contains d orbitals. In these d orbitals, it will gradually or progressively filling of d electrons, progressively filling of the electrons. So this electronic configuration is NS1 to 2, N-1D 1 to 10. That is the general electronic configuration of the D block elements. Here we will go for the 3D series, that is 3D 1 to 10, 4S 1 to 2. That is about the 3D series. Simultaneously 4D series, it is 4D 1 to 10, 5S 1 to 2. 5D series, it is 5D 1 to 10, 6S 1 to 2. So That is the general electronic configurations of these elements. Here the last element which is present in the 3D, 4D and 5D series are zinc, cadmium and then mercury. That means these last elements we have the completely filled d orbital. That means for example we will go for the electronic configuration of zinc. It is 3d10 4s2. Whereas for cadmium it is 4d10 5s2. Whereas for mercury it is 5d10 6s2. So these are all having completely filled d orbital. That means there is no unpaired electron in this elements or elemental state or in the ionic state. So they will show only +2 oxidation state. They will show only the +2 oxidation state due to the removing of these s electrons. Removing of these s electrons present in the zinc, cadmium and then mercury. So that is about the electronic configurations of the elements. We will consider this as these d block elements also called as transition elements. Why they are called as transition elements? They will show a transition between the s block highly electropositive s block elements and highly electronegative p block elements. So they are called as the transition elements. In other words, a transition element is an element in which it has at least one unpaired electron in the d orbital. That is the main important definition. Transition element is defined as which at least one unpaired electron present in the d orbital. It is called as the transition element. అంటే కనీసము ఒక్క అన్పైడ్ ఎలక్ట్రాన్ ఒక్క ఒంటరి ఎలక్ట్రాన్ అయినా సరే డి ఆర్బిటాల్లో ఉండాలి. ఉన్నప్పుడు మాత్రమే మనం ఏమని పిలుస్తాం, వాటిని ట్రాన్సిషన్ ఎలిమెంట్స్ అని పిలుస్తాం. సో ఈ ట్రాన్సిషన్ ఎలిమెంట్స్కి ఇప్పుడు మన ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఎలా రాయొచ్చు అంటే NS122 N-1D N-1D129. That means D10 configuration, it is completely filled. So it is incomplete filling of d electrons. So it is D129. That is the general electronic configuration of the transition elements. So here we will consider for zinc, cadmium and mercury. These are all having the D10 configuration, N-1 D10 NS2. So that is the general electronic configuration of these three elements. So they are called as the only d block elements but not transition elements, because they have no unpaired electron in their valence shell, but not the transition elements. That is about the difference between transition elements and the non-transition elements like zinc, cadmium and then mercury. So next one, what is the position of transition elements in the periodic table? We have already known the position will be in between the S and P block elements. Between S and the P block elements, it will show a gradual change from highly electropositive elements to highly electronegative P block elements. So that is about the transition elements. These are in the 3 series we have known, that is 3D series, 4D series, 5D series and then 6D series. 3D, 4D, 5D series, these are all contains 10 elements each, whereas in 6D series it is incomplete. It is the incomplete series. And next one we will go for the electronic configuration. So we have already known the general electronic configuration of d block elements. It is 1s122 N-1D 1 to 10. So that means this n minus 1 orbital, that is called as the penultimate shell. It is called as penultimate shell. One shell before the valence shell, it is called as the penultimate shell. So there is a small or little energy difference. Little energy difference between the ns orbital and n-1d orbital. There is a small energy change or very small energy change in between the ns orbital and then n-1d orbital. So due to that small change, the electron will shift in these two orbitals. That means in ns to n-1d orbital or n-1 to ns orbital, there is an interchange of electronic or the inter-electronic transitions will occur in between the ns and n-1d orbitals. So very easily, due to the small difference or very little energy difference in between ns and n-1d orbitals. So it will give the more stability of the d block elements. That means either by the completely filled orbitals or by gaining the half filled configurations. In 3D series, so we have the half filled configurations. Half filled configuration. In 3D series, it is chromium. In 3D series, it is chromium. 4D series, it is molybdenum. In 5D series, it is the tungsten or wolfram. So here chromium, we have known that 3d5 4s1 instead of 3d4 4s2. So half filled configuration is more stable. So its electronic configuration will be slightly changed to 3d5 4s1. Whereas molybdenum, it is 4d5 5s1. Whereas tungsten, it is 5d5 6s1. So that is the electronic configurations. And next, in the completely filled configuration. In 3D series, it is copper. Copper is having 29 and its outermost electronic configuration is 3d10 4s1. That is completely filled in 3D series. 4D series, it is the silver. In 4D series, it is the element is silver. It is containing 4d10 5s1. In 5D series, it is gold. That is 5d10 6s1. So these are the elements which completely filled and half filled electronic configuration. They are more stable. Here we have zinc, cadmium and mercury. These three are represented as ns2 n-1d 10 because they are completely filled, having electronic configuration in their atomic state as well as in their ionic state also. So they will all show the only +2 electronic configuration. D orbital has the less penetrating power. Than S and P orbitals. It has the less penetrating power than the s and p orbitals. So it is highly influenced by the atom or ion or the nucleus. So it is highly influenced by the, or it is highly attracted by the nucleus or the other molecules. It is highly influenced by the other molecules. So, and ions with same number of electrons show similar properties. Similar properties like electrical and magnetic properties. They will show similar properties. So we will discuss some of the characteristic properties of d block elements in detailed way. What are those main characteristic properties? First one is the formation of colored ions. Formation of colored aqueous ions. And second one is the different oxidation states. A single element will show different oxidation states. And third one, ability to form complex compounds. And fourth one, catalytic property. So these are the important characteristic properties of the d block elements. We will learn later in a detailed way. So that is about the d block elements and the introduction of the d block elements and f block elements and their properties and what the in which way the properties are changed. So that is about the properties and the characteristic properties of the d block elements.